In this video, I'm going to explain how to use right triangle trig to find missing pieces in a right triangle. So there are three trig functions we will be using: sine, cosine, and tangent. So something a lot of teachers do is give the students this reminder of what goes with each one. So, ka, toa represents sine, so the S is sine, is opposite over hypotenuse. So the O and the H are the opposite over hypotenuse. So this is how you would set up your equation to solve for missing pieces. The cosine is ka, the C stands for cos, A is adjacent, H is hypotenuse. And TOA is your tangent. TOA stands for tan equals opposite over adjacent. So we use these shortcuts to represent the sine, cosine, and tangent. When you are looking at what you're missing in a triangle, you should label the sides that you need. Now, sometimes I've got two missing angles, and so I'm only going to focus on one at a time. So let me just take the Z off. So ignore it for a minute. You can cover it up or just tell yourself, I'm going to ignore this other angle. So you say, with respect to this angle, well, first of all, I think it's easiest if you always find your hypotenuse. Whether you need to know the hypotenuse or not, find where it's located. It's always opposite the 90. So there's your hypotenuse. Now, the other two sides have to be the adjacent or the opposite. So across has to be the opposite side. So that leaves this for the adjacent. Adjacent is next to, but it cannot be the hypotenuse. So with respect to the y, what two sides do we need? Here is our missing angle. We do not want to throw in another missing side. We need to use the two sides they gave us. So they gave us the adjacent side and they gave us the hypotenuse. So come up here, which one has adjacent and hypotenuse? That is cos. So I'm going to grab the cos formula. So I'm looking for y. So you always put your angle measure right next to it, right next to the trig function, the adjacent side length over the hypotenuse side length. When you are solving for this y, you have to do the inverse of your cos. So it's going to be rewritten cos inverse, which is on the calculator, you're going to see a -1, but it's like an exponent. It just represents the inverse. It's not really an exponent of a -1. It's just the inverse. So let me raise this up. There we go. And then the fraction. And if you feel more comfortable putting a parenthesis on the outside, you can do that as well. So you are simply going to find the cos inverse on the calculator. It depends on what kind of calculator you have. And then type in 8/22. So this is the step you will always do when you're looking for an inverse. I've gone into my Desmos calculator and I wanted to show you, so whether you're using a Desmos calculator or another calculator, you will want to make sure your calculator is in degree mode. So if degree is not highlighted, you will not get the right answers. So that's one of the things you're going to want to make sure you do. And on Desmos, so I went and got the Desmos keyboard, the cos inverse is here. So you type in cos inverse, and I know you can't completely see all that. Let me reduce the size. Okay, that helps a little bit, but you still can't see the complete cos inverse over here. And then it was already forgotten, 8/22. So 8 divided by 22. All right, so it just depends on how you're rounding. Let's just round it to the nearest whole degree. So this would be a 69-degree angle. Put a degree mark on it. All right, so now we know I did round it. So when you round, that's going to cause some issues. You got to be real careful because we know this is not exactly 69 degrees, which means when we find this other angle, it's not going to be exactly that measure either if I round it to the nearest whole number, but we just have to realize that. So our answers might be slightly off. So you have to know how picky the paper that you're doing is. How do they want it rounded? You really typically do not want to use rounded answers in another problem. So you want to try not to do that. But if I want to know now this angle, remember all three angles in a triangle add up to 180. Here's 90 of that 180. So if I will take 90 from 90 minus 69 to find this angle, that would be how I could do it. Or I could say 90 plus 69 from 180, but it seems simpler just to do this. So figure out what 90 minus 69 is. So 90 minus 69 is 21, and I went and inserted my 21 into this angle. So I actually know Z now, so that was Z. All right, so I'm still needing to find X. I could actually do Pythagorean theorem at this point. The great thing about Pythagorean theorem is I'm not using these degrees that I have rounded in my problem. So I would now type this into Pythagorean theorem. So stop the video and you use the 22 and the 8 in Pythagorean theorem to find X. I like to find my answer to a Pythagorean theorem problem all in one step. So I will take the square root of the hypotenuse squared minus the leg squared. If I know the hypotenuse, I know this side sign will be a minus. If I do not know the hypotenuse, I can do the same thing, square root of the two legs squared with a plus sign. And you can get it all done by typing it into the calculator all in one step. So notice how I used the approximate symbol because I had to round this answer. So X is 20.5, and it should be less than this because your hypotenuse is always the longest side. Now let's look at this problem. This time we know one of the angles. So I can find Z very simply by taking the same method I did over here. So I'm going to copy this and paste it and just change it to 90 minus 36, which would be 64. 54, excuse me, 54. 4 and 6 is 10, 5, 6, 7, 8, 9. Okay, just want to make sure I did that right. So Z is 54. Now, I did not have to round that answer. I could use my 54 or my 36 when I'm looking for the X or the Y. I'm just going to stick with the 36 for right now. And so I want to label, with respect to the 36, the hypotenuse and the adjacent side and the opposite side. So I always like to go find the hypotenuse first. It's opposite the 90. Across from the 36 has to be the opposite side. So that means this side is adjacent. So if I want to find X first, I notice that this is opposite, and I need to use the side that I have a length. I don't want to use this side. I don't know what the length of that is. I don't want to use two variables in a problem. So one variable and a number is what I kind of go for here. So that is opposite and hypotenuse. Look, opposite, hypotenuse. It is a sign problem. So I'm going to grab this sign equation. I'm going to put 36 beside my trig function. So it's always trig function, degree measure, and then your ratio. So opposite is x, hypotenuse is 12. The way you want to solve this is basically it's a cross multiplying problem. And notice how the 12 is across from the sine of 36. So I'm going to rewrite this before I try to type anything into the calculator. So when I multiply, see, if I think about multiplying something times the x, this sine of 36 could be over 1. And so 1 times x stays x. But over here, I need to type in now 12 sine 36. So stop the video and go type that in. So you got a 7.1 for your answer. Notice how I used the approximate symbol. That is because I rounded it to the nearest tenth. So I know that x is about 7.1. Okay, technically I should have a approximate symbol right there. Now, my job is to find y. Well, I could use Pythagorean theorem. I could say square root of 12 squared minus 7.1 squared, but then I'm using a rounded answer. So I really try to stay away from using a rounded answer within a problem. So let's again use some trig. So I don't want to use this opposite side at all since I rounded this answer. So I'm going to focus on my adjacent side and my hypotenuse again. So adjacent and hypotenuse is cos. So I need to use cos again. So let me drag this problem over here and change out these numbers. So I'm going to use my 36 again. Adjacent is y, and 12 is my hypotenuse. So we're going to do the same thing we did here. 12 cos 36 equals y. So stop the video and go find out what 12 cos 36 is. So I'm sure you got about 9.7. And I came up here and put it on my triangle. All right, so these problems have a variable in the numerator. So next, I want to do a problem where the variable is in the denominator. If you have this problem and they're wanting you to find x and y, and they gave you both of the angles, even if they didn't, if they gave you one, you automatically know the other. So you just need to pick which angle you want to come from. So I am going to come from the 51 just because I want to make sure my x is in the denominator. So I'm kind of ignoring the 39. So the hypotenuse is the hypotenuse. It's always opposite the 90. It's the opposite and adjacent that change depending on which angle you use. So since I'm using the 51, opposite is here. Adjacent is next to it. So opposite is across, adjacent is next to. If I had used the 39, opposite would be on that side and adjacent would be on this side. So it depends on which degree. So I am focused on the 51. I want to find x first. So with respect to this 51, I've got an opposite and a hypotenuse. Opposite and hypotenuse are sine. So I'm going to grab this sine equation that I used previously, and I will change that to a 51 because I'm using that angle. Opposite goes on top. And this time, I'm looking for my denominator. So I have a variable in my denominator. When this happens, and remember we were saying you should cross multiply, when I cross multiply the x on this side, x is not by itself. So I would have to divide by a sine of 51. If you realize you have x in the denominator, basically just flip-flop the x and the sine 51. And so you will have x equals, let me go get a fraction. 14 doesn't go anywhere. But the sine 51 and the x have traded places. So sine 51. So stop the video, This time you're going to go type in 14 divided by sine 51, and let's round our answer to the nearest tenth. So your answer is 18.0. I believe after the, or I should say 0, but after the 0 was a 1, so 18.0. So now let's still use 51 and solve for y. So this time, with respect to the 51, this is opposite and adjacent. So finally, we get to use tan. So tan of 51 equals 14 over y. Y is in our denominator. When your variable is in the denominator, just flip-flop or trade these two spots. Okay, so it's going to be like this. But we have y's instead of x's. And it's tan instead of sine. So stop the video and go find out what 14 divided by tan 51 is. So now you end up with 11.3.